Hello. I think I'm on. All right. Welcome back. It's a late night hacker streams. 10x streams. Here we're 10x engineers. 2x. At least 1.5. All right. So last time I made a little data set based on my GitHub data, which looked like this. Pretty much just prompts where for every code file I have, just JavaScript files now, for all the projects I did, I'm making a data set where pretty much I give myself, my name's Jared. That's why it's Jared. I give myself a task, I give myself the task description, in the task file name, and the code here, and hopefully we can get a data set that we can fine tune some sort of language model. I tried with StarCoder. I actually figured out how to generate using PEFT. Apparently it's only by token, not by context, so it only does it character to character. So really, if you're new to, it's a little background. If you're new to all these concepts, I'm going to run through a lot of the concepts around machine learning, PyTorch. If you're just a person who knows Python or you know JavaScript or whatever, and you don't actually have any idea what I'm talking about, I'm going to help you out here and try to sort of give you some knowledge so you can go off in the world and train your own language models and be comfortable. I'm traditionally a software engineer, front end, back end, a lot of like Python, a lot of JavaScript, Node.js, a lot of PHP, Ruby, things like that, and also a lot of front end stuff. So React, Vue. More recently, just vanilla JS and jQuery throughout the years. That's my arena, and this past year I've been self-learning a lot of machine learning, and I'm telling you, best thing you could do right now is get really comfortable with PyTorch and also NumPy in terms of the technologies, but also get really comfortable with the concepts and the terminology when it comes to like neural networks and things like that. If you really want to get to that 10x, you want to become that 10x. But here, we're trying to get 20x. That's what the people don't understand. Okay. But the real hacker Valhalla is when you get to 20x. That's when all your coffee's free at those companies. Okay, so here I have a Google Colab. Actually, before we get into Colab, I'm gonna run through Llama 2 and what is it. I'm going to be learning here with you guys a lot of this stuff because like I said, you know, my background software engineering, self-learning, a lot of machine learning. I'm actually starting a company using some of this machine learning concepts, so which is like hilarious that I just started learning it, but and I'm like talking to like clients. I'm like, "Oh yeah, no, yeah, I can do that." Yeah, I looked that up yesterday. Just kidding. All right, so Llama 2, little background. You have this concept of, I'm actually going to go into, I could just talk through it. Visuals are nice, but Llama 2 is this new, this is the Hugging Face for it, which is almost like a GitHub for data science people, for machine learning stuff, for really mostly for transformers. That's at least what a lot of the tooling is, and I can get into what transformers are in a little bit, but right now Llama 2 is the sequel to Meta, Facebook. The open source model they made, which was like open source, not fully open source. This one's way more open source, but they made a language model that's super powerful and they made a new iteration of it, which actually is released super well, where you can straight up use Hugging Face and their tools to get the model after you accept terms and conditions, which, you know, after you get in the system, right? If you sign away your soul, but yeah, they have 12 models, which is cool. So they have, and it looks like you can fine tune it on single GPUs, and they have some examples for that. I'm actually using an example that does from StarCoder, which is a separate LLM that just came out for code. So the difference between an LLM and an LM. So we have this. So let's actually make some notes for you. Let me make this big. I'm using Sublime Text because you know I'm 10x. So you know, if you use VS Code, I like have VS Code right here. But if you use VS Code, you can't get to 10x. I'm sorry. It's just, you'll always be at 9. And it's embarrassing. Actually, though, I hate VS Code. It's like so heavy. But anyway, so LM v LLM. So far, we're talking about LLMs. We're talking about LLMs are two things. This is like right now. This is how my education around these things. This is what I've come down to sort of notice about LLMs are right now two things. Hold on a sec. One, they are trained on a ton of data. So that's what there are sensors here. Two, they typically have human reinforcement, human feedback. I think it's RLHF. Let me just double check. I don't want to like all these fucking acronyms, effing acronyms. RLHF in their training process. So really actually maybe that's not, they are optimized. So this is the two main things that separate LMs versus LLMs right now that I'm noticing is in typical language models, which we had another video where we made a language model with basic Word2Vec, and we used that to cluster some job applications so we could find similar jobs. You can check that video somewhere else. We made that a few days ago. So what we're doing now is dealing with LLMs now. What I'm noticing about LLMs right now is they're just using a ton of data. They have so many parameters, and they're typically 7 billion and up, 3 billion and up parameters. And actually, you can look at the Open LLM leaderboard. I've been messing around with a ton of these and reading their white papers just to sort of get this world, because all this language model stuff is so fascinating. I love it. Because I don't want to code anymore, and why is this taking so long? So I don't want to code anymore, and this seems like the best chance I have to never coding again. So, really, so why are they not showing? So I'm going to the leaderboard and it's just empty. I was like hyping this shit up. What is it? Okay? Let me refresh. Whatever. It's not even like a big deal. I just wanted to show you guys this. So, okay. Alright, I guess I don't get that today. I don't deserve that. Alright, so either way, there's like this Open LLM leaderboard, which is like really Hugging Face, which is sort of this big repository of language models they have a ton of different resources for interacting with language models based on transformers. By the way, language models in the modern age are using transformers. That's just the way it is right now. You used to have LSTMs, and you used to have like what was before, RNNs before that, and now we have transformers. Attention is all you need is a paper, I believe, coming from Google that kind of pushed us into this new realm of transformers. And really the base concept around it is around attention and self-attention, in which the neural net is sort of training these word embeddings. Really, a lot of this is just the same word embedding stuff we were using in the last video. A lot of this appears to be super complex word embeddings. The transformers are essentially each individual word, the learning of the representation of that word stems from its attention. So mechanisms in which you're sort of like, what's a good way to say it? They're doing matrix multiplication with matrices that are essentially ordered in a certain way, in which the position of this word embedding is sort of gaining its the math is sort of moving in the direction of that word, so that it's the relation to other words, and its relation to other words impacts this vector. Long story short, I guess, like, rather than just looking at the word in context to other words, you're also looking at how other words sort of draw attention to each other. I'm not, by the way, I'm not like look it up. That's me sort of distilling the information to you from a newbie's perspective. This is like, I got a lot of engineering experience, but not a lot of machine learning experience. So this is me distilling that to you. Do your own research. So that's really the transformer side. The RLHF is this. So there's reinforcement learning, which a lot of these models are getting trained nowadays with this reward mechanism, in which you're rewarding the model through certain decisions in order to reinforce behavior. Same way as you get carrots and sticks when you're learning as a child, right? It's like, don't do this because, like, bang, you shouldn't hit somebody, bah, I'll hit you, you know. So then you learn peace, or you learn how to be a little. But either way, so they're using human feedback reinforcement learning, which is, they talk about a lot, and we'll actually run through this a little bit. So a lot of the reinforcement learning, I wish I had a way to draw here. Maybe we'll get an extension for that. But a lot of this reinforcement learning is all about, yeah, so like they do it in their loss function. So like cross entropy loss, which is the loss that's used to kind of, for a lot of these transformers models, for token prediction, they're kind of like augmenting a lot of the loss using this human reinforcement feedback, where they have these actual literal people that will say, based on the predictions that get made, that it will say, oh, was this essentially they'll have a human response and they'll have the AI response, and they keep rewarding it to align more with the human response, sort of to make order out of chaos is what it appears to be. Because, you know, the way humans act, there's a lot of chaos into the natural world and how humans will behave when it comes to responses to things. They're kind of trying to teach the AI to deal with a lot of this chaotic forces, which seems to be, from my new perspective, it seems to be the most important part of a lot of this new development in language models, is trying to make order out of chaos, which might be impossible. I don't know. Interesting. So they're saying, so what does this mean? So they're saying the output being a scalar. Let me read it. So they're saying generating a reward model also referred to as a preference model, calibrated with human preferences, so that the human responses, and also the yes or no is human based on whether this response is good or not, is where the relatively new research in RLHF begins. The underlying goal is to get a model or system that takes in a sequence of text and returns a scalar reward which should numerically represent the human preference. So it seems like the output's going to be just a number, which is interesting. The system can be an end-to-end LM or a modular system outputting a reward. A model ranks output and the ranking is converted to reward. So the output being a scalar reward is crucial for existing RL algorithms being integrated seamlessly later in the RLHF process. These LMs for reward modeling can be, and by the way, this is important because this is what separates Llama from a lot of other LLMs right now, is that they have the resources to do this well. A lot of people don't. A lot of these open source models don't have the resources to do. Love it or hate it, Meta's got money to pay people to label things. Okay, so especially initializing these models after pre-training. Training data set of prompt generation pairs for RM is generated by sampling a set of prompts from a predefined data set. The prompts are passed through an initial language model to generate new text. Human annotators are used to rank the generated text outputs from the LM. One may initially think that humans should apply a scalar score directly to each piece of text in order to generate a reward model, but this is difficult to do in practice. The differing values of humans cause these scores to be uncalibrated and noisy. That's interesting. Instead, rankings are used to compare the outputs of multiple models and create a much better regularized data set. Interesting. So they rank. So this is interesting. So because a lot of people talk about how ranked voting makes more sense in a democracy sense. I don't really agree, but I think that it's interesting that they're seeing that ranking these outputs make more sense than applying scale. They mean applying like a number score to it. Because it's probably because when you're dealing with a lot of different humans that are scoring these things, you're probably all these different people. It's almost like, I think the problem they're hitting here, what they're saying, is almost as if you had to tell 10 different guys to give 100 different girls a score out of 1 out of 10. And it's like everyone has their own biases that lead to, like, some guys may never want to give a girl under a score of 5. Some guys might be brutal. You know what I mean? So that would probably lead this to, you wouldn't have a normalization around that because of the biases, and also the different, like, how people score things is just like different. So I think ranking makes more sense. That's actually cool. So they said there are multiple methods for ranking the text. One method that has been successful is to have users compare generated text from 2 language models. Now, if you're watching right now, we're looking through the reinforcement learning human feedback, how that's done, because the model we're about to mess around with uses that, Llama 2. So they say by comparing model outputs in head-to-head matchups, an ELO system can be used to generate a ranking of the models. Let's look into this. If you watch my video on software engineering fundamentals, you got to know everything, and I don't know ELO. It sounds like what's used in chess, but yeah, it is what's used in chess. I just needed to, the FIDE rankings are based on this. I'm not really a chess guy. I play it casually. Okay, so these different methods of ranking are normalized into a scalar reward signal for training. Maybe, and I'm guessing that signal's like out of some threshold, that means it's good. I don't know. An interesting artifact of this process is that the successful RLHF systems to date have used reward language language models with varying sizes relative to text generation. OpenAI's 175 billion language model, 6 billion reward model, Anthropic used LM and reward models from 10 billion to 52 billion. DeepMind uses 70 billion chinchilla. Okay, all right, we don't have to read all that. The intuition would be that these preference models need to have similar capacity to understand the text given to them as a model would need in order to generate said text. Okay. This point in the RLHF system, we have an initial language model that can be used to generate text and preferences. Okay, all right, we get it. So we want to get into fine-tuning. So how are they actually fine-tuning this? So training a language model with reinforced learning was for a long time something that people would have thought as impossible for engineering and algorithmic reasons. But multiple organizations seem to have gotten to work in fine-tuning for all parameters of a copy of the initial LM with a policy gradient RL algorithm, proximal policy optimization, PPO. I've heard about that. I don't know a lot about that. I want to look into that. Well, I'll do that later. So parameters of the LM are frozen. So this is where we get into low rank adaptation, which is I've been looking at this week and how that works. Long story short, that's what I'm about to do. So I'm about to use LoRA, low rank adaptation, to fine tune the model because I don't have a crazy amount of A100 GPUs because I'm not fucking rich. Effing rich, sorry. Sorry, YouTube. I think they don't like that. So I'm using Colab. So, which, Colab is cool. I like Colab personally. I think that at the end of the day, you can kind of get by just using something like Colab, training most of what you want, and using things like low rank adaptation. It's really cool. Long story short, turns out when you're fine-tuning these models, you don't actually need to update all the weights with these new prompts, with these new inputs. So what I mean by that is what they do is they actually, which they're saying here, they freeze a lot of the parameters. And by the way, when you hear someone say parameters are frozen, they're talking about the weights. So be very clear about that. Because a lot of people don't understand what they mean by parameters. And if you don't know what they mean by weights, whenever the model's training and you're doing a forward pass, it's updating the weights. So each of these neurons is resolving using a function to a certain number, which it's retaining some knowledge based on if you're doing supervised learning on the supervised output. And when you do that gradient descent, you're slowly over time, as you do the back propagation, you're updating these weights to align to what will get you that predicted output. So that's when we're talking about weights. We're just talking about all those numbers, right? We're talking about all the parameters of the model. And when they say 175 billion parameters, it's 175 billion little numbers. Like vectors or whatever. So frozen because fine-tuning entire is expensive. And you got to think about it. If you have billions and billions and billions of these things, you have to do billions and billions of operations. So it makes sense why you would need a GPU, because you have to do a lot of things in parallel. That's me using my coder brain to apply to machine learning. I'm like, I know as a coder, right? Like I know the significance to doing a ton of operations and how much. If I do 8 plus 8, that registers have to be used in the CPU. Memory cells have to start to retain and release and trigger. Like the transistors have to move in order to allocate the memory needed to get 8 plus 8, right? And then 8 plus 8, if you do 8 plus 8.8, all of a sudden you're going to have to deal. So the reason why floating point precision, just an aside, is so important, because you think 8 plus 8 is just 16, but it really isn't. Because what happens when you start doing 8 divided by 3. Then all of a sudden you have these, you have like, you know, I don't have a calculator out, but you have like a ton of, let me just get, it's the fastest way I can get to a calculator. But what happens when you do, well, what happens when you do like 2 divided by 3? It's like you have 0.6666. You think about memory. Each one of those 6's need to be accounted for. It doesn't make, because you're like, oh, well, I know it's 0.66 rounded, right? Or 0.67 rounded. But the computer has to account for all those numbers. So whenever someone talks about floating point, they're talking about the amount of precision you need. So like this looks like 16. Let me just, yeah, this is 16 floating point precision. And this is important because we're about to get into what, this is actually a very good aside because we're not going to get into a lot of the ways, the quantization, what a lot of people are using to make sure there's less memory being used in these registers, in the GPU, utilizing these registers in order to make this stuff faster. If you're a coder, that's why you have to understand a lot of things and not just know how classes work, right? You need to know about memory, you need to know about the heap, you need to know about the stack, you need to know about a lot of different concepts because it makes everything better. But anyway, so like in quantization is like, so you saw how that was 16 numbers. That could have been just 8 numbers. 0.66, like that's the same thing, right? For 90% of operations, those extras, and when it comes to machine learning, not other parts of computing, but when it comes to machine learning, most of the operations you're going to want to do for predictions don't need all 16 or 32 positions of floating point. So you can do 8, right? Some people are even getting by doing 4. So that's what's making it faster for a lot of these things. And we'll see how that works later when we get into the code. For now, we're not getting into the code. So, all right. So, yeah, he says there's tons of guides on how this works. I feel like, proximal policy optimization. I'm pretty sure that's a lot of the concepts we're talking about, but the terminology I'm not 100% about. First, the policy. Policy is a concept in reinforcement learning. I just don't know the proximal part of it. So the policy is a language model that takes in a prompt and returns a sequence of text. Makes sense. That's what's happening. The action space of this policy is all the tokens corresponding to the vocabulary of the language model. So pretty much the action space. So when we're talking about space in these language models and these neural networks, what we're talking about, this is me translating this to you. So what we're talking about is the distribution field. So it's like, so if you have, we're talking about the feature space. So like vocabulary is the feature space. So it's like whenever you have a neural network, the features are the things that you use in order to I guess like it's the scope in which you can deal with the problem. So if you're doing a classification problem, you can classify with 10 different things, right? And these are the outcomes. And maybe in order to classify it to 10 different things, you use 100 different features. So it's like the human face, maybe the eye color is a feature, and like lips, width or whatever, pigment, these are all features. And when they're talking about action space, it appears like they're talking about, and they say 50K tokens. So there's 50,000 tokens in those are the features. Okay, so the observation space is the distribution of possible input token. I'm just thinking about money, income. It's the distribution of possible input token sequences, which is also quite large given previous uses of RL. Okay, so it seems like observation space is just how much the model is seeing in terms of the possibilities that can happen. The reward function is a combination of the preference model and the constraint on policy shift. The constraint on policy, I don't fully understand that. But the reward function just appears to be just like the, I think it's all this stuff to determine whether the scalars are doing good or bad that get returned. Oh, they say it right here. Okay, the reward function is where the system combines all the models we have discussed into one RLHF process. Given a prompt X, this is important. Given a prompt X from the data set, the text Y is generated by the current iteration of the fine-tuned policy. Concatenated with the original prompt, the text is passed to the preference model, which returns a scalar notion of preferability. And then in addition, per token probability distributions from the RL policy are compared to the ones from the initial model to compute a penalty on the difference between them. So pretty much they get the delta between the probability per token in the policy, and they compare with the initial model, so before the training, to get the penalty using the outcomes of the reward model, it seems like. So really that scalar notion of that's whatever scalar they get in the end, whatever number they get, they compare with like the original probability per token to see, which is not good because it's the initial model. And then that's how they get I believe the difference between those is how they figure out what's good or what isn't. So, okay. KL divergence between these sequences. Okay, so term penalizes. So that's actually that's a good amount. I don't want to run through the whole thing. Let's go back. Let's go back to Llama. So back to Llama. See, we just did a deep dive and now we understand this. And now when we go back to understanding Llama 2, we're actually going to be a little bit better. So across a wide range of helpfulness and safety benchmarks. Now we get into the bullshit. It's like what they do, all these things they do to try to evaluate these models to get to like being non-toxic. This may not be related. I may be just freaking out over nothing. But all the things they do to get like non-toxic, it's like what are we doing? Really? We're doing this in engineering now? We're being like, we have to make the AI a safe space? What? I just sound like a meathead. Alright. It's true though. It's like what is the actual benefit of that? Words don't hurt people. Okay, so, and if they do, just don't go outside. Alright, so here are the models that they have. Oh wait, this is Falcon 7B. That's not related, but they're comparing it here. And then they have, they're comparing it to, so they're kind of just saying it's better, especially the chat one. They're just saying it's better than Falcon. This star, I don't know why there's a star there. Oh, star, oh, they're still doing evaluations for that. Okay. There's a demo of it, of the chatbot. Let's try it out. So, let's see. What's like a good thing? Hi. What can you help me with? So they're saying, please feel free. Alright, and then they're like, I will not provide answers that contain harmful, unethical, racist, sexist, toxic. Well, you can't help me out then, because how much? That's all the stuff I wanted to ask. If you're not gonna ask me, I mean, if you're not gonna, I'm like, I sound like an idiot, but like, if you're not gonna answer about harmful, unethical, racist, sexist, toxic, dangerous, or illegal content, then you can't help me out. All right, so what is your body count? I don't have a body count as I do not have. Oh, they think I'm asking. Okay, what is your body count in terms of, like, you know? Okay, all right. So they still don't get it. What is your? This is why no one, like ChatGPT, at the end of the day, it's so flawed, and Llama appears to be as well. All the stream when I try to train a based model using some based content, but like for now, like this stuff sucks. All right, so what is your body count like in terms of dating? I don't have a button sense. I'm not. All right, well it doesn't get what I'm talking about. Oh, okay, no, it does. And it says addition. Oh, dang, it's saying a ton of stuff. Oh my god, it sounds like HR. Additionally, it's not appropriate or respectful to refer to people as a body count in the context of dating or any other. But what if it's like useful in terms of vetting people? Every person has inherent worth. Not really true. I mean, every person like has a spirit, you know, in a spiritual way. But like some people suck. In terms of dating, it's important to approach relationships with respect and honesty and consent. Okay, yeah, I mean, respect is important. It's important to respect the other person's boundaries and to communicate openly. Well, what my boundary is, I don't want you to have a high body count. I guess, see, like logically, what it's saying doesn't make that much sense. But okay, it is giving like a fairly educated answer. It's just woke. Okay, so. Let's see. Has the word agents and autonomy. All right, so let's say what is. I like didn't spell that right. I like can't spell. I'm like learning that. And I think it's because of I'm not gonna blame anyone here. It's me. But it's because of like my dependency on the internet. Definitely. Alright, so it can do basic stuff. So can you give me, so this is now relevant to what we're about to do. We're about to fine tune a language model to help us code like me, using my code. Can you give me a content script for a Chrome extension that injects a iframe into a website? Okay. So it just gave me a ton of white space. It didn't actually do anything. And cool. So it actually didn't work at all. Let's try that again. Let's try that again. Oh, what? That's a good question too. Yeah, it's still not doing it. Okay, so I don't know why this isn't. Can you give me a code snippet on parsing SQL out of SQL injection attempts out of, let me just say, it's for sanitizing user input for a form in JS. Alright, so it's the code snippets aren't actually working. It's not, whatever. I'm pretty sure it works. It's cool that it's actually giving me things on how to do it. So it's actually saying, like, yeah, use, regular expressions to remove HTML tags, special characters. Cool. All right. So let's go and use this. So, yeah, they're using transformers library. Here's like they're showing you like how to use it here. for sequence. In sequence, okay. Using text generation inference is production ready. All right, so let's run through. So I adapted Starcoder's. What's it called? Their fine-tuned script, which is here. I did this last stream. I figured out why the generation wasn't working, by the way. Just look up Starcoder. This is the fine-tuned script. So they open sourced the script on how to fine-tune their. This was like recent too. Yeah, like last month is the last time they updated it. And also when we're talking about fine-tuning, we're talking about how to get a script, get a model, and you have your own data set. And you want to essentially use your data set in order to train the model to be fixated on a specific task. So it's almost like you go through generic boot camp, and that's the LLM is this generic boot camp for the military in which the language model learns all these different fields, and it learns how to shoot, it learns how to, but in this instance it's learning basic text and how to, talk down to you when you want to know what a girl's body count is and stuff like that. But in general it learns a ton of tasks. We're doing when we're fine-tuning is we're getting a data set and we're training the model in order to specifically address a downstream task that we have specific knowledge on and that we want it to be directed towards. Like I said, I want my task to be generating code like me, and I gave a data set. This is very flawed. And by the way, these little tags that I have here, these tags are meant to this is just a way of fine-tuning in which you give it specific indicators that are new, so that with these new specific indicators, these tokens, you're kind of giving it a new framework of how to generate with enough examples. I don't have enough examples here to actually get things working well. In fact, I'll show you the loss was going up with the last thing. Also, I need a ton of examples, and I probably need to increase the batch size. Actually, I totally forgot to check. The training, it looks like I could probably increase the batch size to 2. Because Llama's actually smaller. I'm using the 7 billion parameter one. It's significantly smaller than Starcoder. Okay, but Starcoder, I think it's better for writing code. Okay, so they have this, and I'll talk about PFT and all this, and we'll run through those docs. So they have this script that they wrote that allows you to fine-tune Starcoder, and they use this LoRA model optimizer, which pretty much applies that method of fine-tuning without fine-tuning all the weights, in which it freezes most of the weights except for some of the later layers, so that you're just training layers that matter for what you need. It's called low rank adaptation because you're getting the rank of these matrices, and you're a low rank. So when we're talking about ranking a matrix, you're pretty much trying to find rows that are what's the right term? So that can't be extrapolated. So independent rows. You're trying to find rows that aren't dependent, that you can't do a ton of operations in this matrix in order to get this data. So they're unique. Let me actually just get the actual. I'd be much better explaining this with some let's see. So let me just get it says linear independent columns. yeah. So pretty much like independent because, and I think I said row, I meant to say column, but like they're linearly independent because if they're dependent, then that means that you can pretty much, if they're independent, that means that there's no amount of transformations that you can do with this matrix in order to get those columns. So you're pretty much compressing the data by getting all the unique form of the matrix. It's a way of compressing the data. Okay, so that's not my expertise. Look that shit up. Okay. Now, one of the best things you can do is when you're looking at these scripts. Now, this is what I know, Python. So one of the best things you can do when you're looking at these scripts is you can first try to find the main function. So we already adapted this to our purposes, but we did a couple things. This is what it originally looked like. We broke a lot of this stuff out. And by the way, this is the floating point stuff I was talking about. Actually, let me show you how they initialize it. So at the top, where is it? When they get the model, where do they get the model? That's the data set. Right here. So they'll load an 8-bit. So they're really saying load, rather than rolling 16-bit, loaded 8-bit. I believe the default was 16-bit. And yeah, evaluation steps. So let's actually go to our model. So we messed around with this to the point where and I already started training it a little bit. As you can see, the GPU is getting used, where we kept the functions here. And I want to talk through what's actually happening here, which it was going through it a little bit too fast before. But what's really happening is, let me start from the top. So we're using transformers, which you can get with pip install transformers. If you want to fine tune any of these language models, you have to get transformers first. That's going to give you Torch. It's going to give you most of the packages you need. Let's actually go to our pip install statement. So we get transformers, we get data sets, we get accelerate. I actually don't know if no, that is a separate thing we need to get. And I get accelerate again for some reason. Bits and bytes, I don't know what that is. But we get PFT. This is super important. Last video, I didn't know what that was. I looked it up. I mean, learning about PFT, definitely learn about PFT because that's super important. It's pretty much what the means at which we're using. Let me go to it. The means at which we're using LoRA to get the low rank adaptations, or essentially getting a low rank of these linear independent columns in this matrix, so that we can compress this data, but we're retaining the bits. We're not actually, there's no loss. And it's parameter efficient fine tuning, and what they mean is you're adapting these models by freezing parameter efficient. So you're not updating all the parameters, all the weights. You're freezing some of these layers and the weights within those layers, so that you can just fine tune some of the layers which makes sense, right? Because if you do a forward pass and you're only affecting some layers, you're retaining some of those original, I guess, token space. That's what someone was referring to this recently to me. You're retaining some of the original token space, which matters, but you're modifying some of these little magic numbers so you can get a better one, so it's cost effective, but two, it actually does help when it comes to memorization, which appears to be a big deal. Look up memory look up LSTM specifically and why those were created, and that'll help a lot. I'm not the best person to explain that. I'll actually do a video on it. I'll maybe brush up on RNNs and LSTMs and do a video on it because that stuff's super important. But LSTMs are like the way in which memory was optimized over time and retaining long-term, short-term memory. Seeing how that developed historically just blew my mind. It's just like stuff like that is so cool. All right, so yeah, so they have prefix tuning, which that's sort of like, we can sort of see this here. So that's sort of like doing this prefix. Oh, let's read it here. It's a lightweight alternative to fine tuning for which keeps language model parameters frozen. Instead, optimized sequence continuous task-specific vectors, which we call prefix. So it seems like they just have very task-specific tokens here, kind of similar to what we're doing. So yeah, this is pretty much what we're doing, where we have like this prefix like this. I don't know the difference between this and we're doing prefix tuning, but I don't know. I guess they did prefix tuning while freezing. Interesting. But okay, so we have this LoRA config. So really, this is how you use this package. This is just a way to apply LoRA and these other methods of doing the same thing, where you're freezing the parameters and you're training in a certain way so that it's optimized, so you don't have to utilize all the parameters when you're fine tuning, which can be super expensive when you have these like 100+ billion parameter models. You give it the task type. Oh, interesting. It says sequence to sequence task. And then this is not an inference one that they're using. The R is 8. So the LoRA alpha, the dropout's 0.1. So I guess they apply dropout to these networks. So some of these are getting zeroed out. Okay. So let me see. By the way, I'm not an expert on LoRA, so I actually want to see what a lot of these parameters are before we get too into it, because I like to know before I do, to some extent. Definitely have not known and did. I've definitely not. Yeah, I made mistakes. I bumped my head. Alright, so let me see what I want to actually look at the R. Yeah, it's the rank. Oh, that's the rank of the updated matrix. Okay. Okay. That makes sense. So the R is the rank, the alpha is the scaling factor. The bias is if bias parameter should be trained. So bias is a parameter in basics of all neural networks. Pretty much you apply a bias. It's almost like the Y when it comes into the if you're graphing out these weights, it's essentially scaling it in a direction. And they're just saying whether these parameters, so it's just another dimension to these weights, or to the parameters. It's a parameter that's another dimension to the, I guess, the neuron. And it's like the direction at which, so you have like the weight, which is, you know, mx plus b. That's the gradients are shifting these weights, and the biases get shifted as well. And they're just saying whether you want only the LoRA weights, only the LoRA biases to change, none of the biases to change, or all the biases to change. This makes sense. So what's the LoRA scaling factor? I don't know what that is. Is that just like, is that literally just like another, oh wait, that's not it. But is that literally just another what's it called? Another value that's getting factored into the weights? I think that might be what it is. I just don't know 100% how that gets used. I don't know everything. What can I say? The rank makes sense. That's just like this is just like when they're applying the rank to these, like, yeah, like they say, lower rank results in smaller update matrices with fewer transmittal parameters. So pretty much, you do really small rank, you're gonna get a smaller update. The update matrices are gonna be smaller. And wow, my battery's getting low. Let me deal with that. 1 second. Okay. So I'm back. That was fun, right? Is class still in session? Okay. I was about to die on you guys. Alright, so we have, yeah, so this makes sense. So it's the rank that they wanted to lower it to. The alpha, this is a scaling factor. I'm not 100% on that. I want someone smarter than me to explain that. The bias, which is pretty much whether or not the biases are going to get trained, and then other stuff, which doesn't matter that much. But now we understand more of what that is. Oh, let me reconnect. Oh no, I have to reconnect. Okay, so my stuff's still here. Sometimes this stuff is like, oh wait, am I still running a cell? No, it's not. Okay, cool. But so really, if you want to start, this is a great script if you want to do this yourself. And I can show you how I adapted this script, because sometimes they'll give you the script to fine-tune these models yourselves, but you'll be like, wait, how do I do that with my data? But let's break down everything they're doing, and I'll show you how I updated this with my own data set. And this is actually going to blow your mind. So let's ignore this. This is just a callback they have to save the model. And whenever you see PFT model, they're just saying they're using PFT. They're sort of wrapping this model with a PFT model, which is using the LoRA adaptation, low rank adaptation method, and applying it to the model. That's all it's doing. So ignore those callbacks for now. So they get this character to token ratio. It's just getting the average characters per token. This is getting all the trainable parameters. So yeah, this function, this is a dummy function, but really it's only because they had another more complicated thing happening here. But you can watch the other video a little bit, but really when you want to fine tune one of these models, all you need to do, they make it super easy for you. I love Hugging Face so much, like really love Hugging Face. They make it super easy for you to fine tune models because they abstract all the I/O. So they make it so that one, it's using PyTorch, so you have the same. They have the same PyTorch model built for all these. It has a generate function. It has a train function. You know, they have the forward and the backward, but they have this layer on top of it, on top of PyTorch, in which they have a generate function and they have a train function. They have all these things, and they build that. And they have this class. And this is the trainer. This train class. This whole training here. This is the training loop. So they do all those PyTorch methods inside this loop to train it, and then you pass in all these arguments, which are very similar. Most language models have very similar arguments. These can't be the same. I actually don't know how this worked, those being the same, but so, and then the checkpoints, it's like they just save copies of the model for every checkpoint. I don't know how many checkpoints there are. As you can see, this is what we just went through. So it's a 16. That's fair. It seems high. 16 rank. The alpha is 32. That's the scaling factor. Still not 100% on that. I actually want to load it up as 8-bit. Casual LM. So let's just go to casual LM. Actually, oh yeah, and bias none. So we're actually not doing anything to biases, which I don't know why they're not. They're just not. I don't know. I think we want to. This is specific to StarCoder, this stuff, where it looks like they have like, is this query attention? I don't know, but they have different modules that are getting targeted here. I don't fully know what that is, but we don't need that. So weight decay. Oh, interesting. Anyway, this is the learning rate, which is low, but that's typically learning rate. There's learning rate adaptation happening, which is modifying the learning rate over time. So say pre-trained. All right. So actually what we do is we actually move. So we get our data set. The way I showed you the other video, but the way and you want to do this. So they have this little, data set class, which Transformers, they have, PyTorch has a data set class. Transformers gives you some super classes to use. Hugging Face gives you, with the datasets library, gives you some super classes, some things you can use in order to load datasets from Hugging Face. We're not doing that. We're literally loading up this JSON file that I wrote last video, which I just wrote a script to read some Python files. We don't need that to be that big. To read some JavaScript files from my directory using Node.js script, and I'm literally just creating a data set that looks like this, where for each file I give myself these prefix tokens and title description. Actually, that's not right. Interesting. My bad. We actually want to say Jared title. Yeah. That's probably why it was actually like messed up. That's funny. All right, but recursively get source code. So let's do, and I'm doing the Jared because I want these prefixes to be like pretty similar. And where's description? Oh wow, all of it's messed up. That's so funny. I didn't think about it. That's why when I was running inference on this before, it was actually messed up. You want to have the colon there. So it's actually the way the tokenizer works. I believe Jared, the dash, description, and colon are all going to be tokens. All right, so that's funny. I was like, it's actually a big deal. Let me run the script again, just so I can get a better data set. Experiments. I want to have another video where we really get into data set creation and how you can get your own data sets from web scraping, APIs, whatever you want to do, because that's super big right now. A lot of for us engineers, like you saw, like I'm like butchering a ton of the terminology when it comes to the neural networks. Like I understand how it works, trying to translate it to you, but at the end of the day, us engineers, we build stuff, and a lot of what we need to get good at is getting data, pruning data, organizing it in a way in which we can generate quality embeddings. So at the end of the day, the embeddings are really what matters here for a lot of because I'm making a product now that is translating a lot of these concepts to the real world. I'm telling you, vector searches, which I have a video, actually I don't know if I have a video where I'm doing a vector search yet, but I have a video where I'm vectorizing, where I'm creating word embeddings, and then I'm doing cosine similarity to group things together, or to rank things, which is essentially a vector search. That stuff is where a lot of this stuff becomes applied. A lot of stuff, this transformers you're saying now, becomes applied. I'm telling you, my videos on web scraping, all that stuff, that is so important right now, because at the end of the day, your ability to utilize, also that's why I'm talking about the fine tuning and PFT and LoRA, because if you can train these for downstream tasks on one GPU for your purposes and use a small, like I'm just training a 7 billion parameter Llama 2 model. If you could do things like this, you're going to have such an advantage. It's crazy. You can have such an advantage. And I can actually make this open source. I'm really just adapting their script, so it's not, you could just watch the video too. It's not like crazy. But really, I'm making it in a way that you could just have any text file. Let me just make sure. I do make it into a text file, right? Oh no, the JSON's just an array, right? But you can have any array of text, and then it'll be able to fine tune from that. That's all it's doing. So, right, so I recursively just, really in my script, I just get a ton of, let me run this script again with these changes I made. Puppeteer is the best way to do browser automation. You want to get real world data. Real world data is what matters. Let me see if that should have been quicker, right? So let's see if it's, because these prefix tokens are going to be important. Oh, it already had a colon. My bad. Where did I add the colon? I already have a colon somewhere. Oh, right here. I already add the colon. My bad. I was supposed to say, I feel like I wouldn't write something like that. Alright, so yeah, I'm just doing 3 like directories right now. I should get a larger data set, but this is just for educational purposes. If you really want to be 10x, you gotta web scrape. It's just facts. If you're not good at web scraping, you're not gonna get to that next level where you're like, yeah, I can data set? What? Yeah, I can do anything. You kidding me? Okay, so let's go back to this. So we have, that's our data set. Let's actually delete this file. Let's upload our new file. I want to start fine tuning here just to, wow, I'm running out of compute units. My God, I only have 9 left. We won't be able to fully, this won't fully work. I just want to show you the process from fine tuning this. And I just switched out StarCoder, which I was using, with Llama 2. So if you want to use Llama 2, there's a ton of scripts out there to fine tune these large models. Hugging Face has a ton of documentation. StarCoder was just one of the language models using it, and they had their own open source script to fine tune. So, and just know that it's not like specifically fine tuning Llama. It's, you're fine tuning a language model, a large language model, Transformers language model. And you want to use Hugging Face to do that. Okay, so I loaded it up again, and let me run. That's all good. These are just the classes and the functions. I'm going to run the data set again, which is giving me the train data and the val data. And all I'm doing is literally just saying load meta. And you have to get you have to get access keys first. If you have any questions about that, just ask me. Stuff like that is super easy. You just need to say, it takes them few hours to accept you. But through Hugging Face, you have to accept this thing. And why is this taking a long time? It's interesting. Whatever. Anyway, so these are the two places. So first, we're using the auto tokenizer, which is getting us a tokenizer, creating a tokenizer class for us, which will convert our text, our inputs, into the numeric representations, not vectorizing, where it's the numbers, the input IDs that are going to pass to the model, which will be the IDs in the token table. So when you get your embeddings, if you wanted to create embeddings from this, these IDs would map to vectors. Okay, so why is this taking? By the way, yeah, it's very small data. 6 was the closest thing to, I think I'm doing a rounding on or a seal. I'm just rounding the data a little bit. So 6 is 10% of the data in the validation set. Okay, so this is the keyword I'm sending up to Hugging Face. Oh, it loaded. To say, hey, or this is the parameter I'm setting up to Hugging Face to say, hey, from the pre-trained model, this is a pre-trained model. All these models are pre-trained. Give me the casual. Actually, let's look up casual out. Give you guys a full brief. So but pretty much that's loading up the model. So there's 2 types of language modeling, casual and masked. This guide illustrates casual language modeling. Casual language models are frequently used for text generation. You can use these models for creative applications like choosing your own text adventure, an intelligent coding assistant. Okay, so casual language modeling predicts the next token in a sequence of tokens. The model can only attend to tokens on the left. So we're really talking about GPT versus BERT, as it appears like. By the way, there's so many concepts coming out now that don't be afraid to not know anything. Just look it up. That's what I do. I'm what's casual versus masking? I just look it up. And now I understand. Okay. Oh, interesting. So this is more so, this is really just saying autoaggressive. Let me get like the actual explanation. Oh, okay. So it's the to predict the masked. Let me just read. Let's read what this guy has to say. So we mask a certain number of words in a given sentence, and it predicts the masked words. Right. So it's like fill in the blank model, and it's bidirectional, and that's how BERT is. And the alpha is the attention weights. The casual language model is unidirectional, and it's like GPT, dyslexic, and it says it's similar to the LSTMs. Okay, it makes sense. So now to go back, now that we educate ourselves into how things work, let's go back into, so they're saying, give us the model. And as you see, I commented out StarCoder. I literally just replaced StarCoder with this. That's how seamless, orthogonal in nature these Hugging Face is. Device map. Okay, so and also they're saying for int 8. So I believe that's simply just because we're using bit 8, we're loading it in bit 8. Okay, so in this is, we kind of went over this. And then the task type, we're saying it's a casual LM task. I'm assuming that's something that they understand. The model, by the way, this is all adapted from StarCoder's fine-tuned script that they gave us. Start duration 0, and so the training arguments, this is really important. You're going to be messing around with this the most. These are your hyperparameters. Whenever someone mentions hyperparameters, they mean, oh wait, why my computer units are just going down right now? Am I running stuff? Oh, you know why? Because it's loaded in the GPU, and I think even when you don't do stuff, it gets messed up. Alright, whatever. So we have the max amount of steps as a hyperparameter, the evaluation step. So each time it gets evaluated is going to be at 100. So I said the logging step, so I want to log every 10 steps just because this kind of takes a while. It's a big deal, so I'm actually saying for the train, do 1 batch size, evaluation, do 1 batch size. So we're actually not doing 2. I think it would actually be too crazy. Let's try. Well, yeah, let's try. It might break. Scheduler type. So this is scheduling the the learning rate. So the learning rate's actually getting updated here. Warm-up steps, gradient accumulation steps. What? Wait, hold on. What is that? I'm learning with you. There's a lot of gaps I'm filling out. Okay, gradient accumulation is where you can train on bigger batch size than your machine. Oh, I'm guessing this is something Accelerate does. That, yeah. So when you have bigger batch sizes, it accumulates the gradients over a lot of batches and then optimizes in one pass, which why I don't think with this matters that much for us, but that's fine. It'll make it optimized. We're not checkpointing the gradients, like I said. So this is B float and float, but really we're just saying use floating point 16, weight decay. Oh yeah, we don't. This doesn't matter. This is the name of the run here. I think that might be the name of our outputted checkpoint. Let's see. I don't know. But Okay, so this is for port 2 thing. It defaults to WandaDB. I was like so mad at WandaDB last stream because it just kept being like, oh, I'm just losing compute units like by the second. That's hilarious. I'm not even doing anything. All right. It's Collab. I love it to death, but it's such a scam. Anyway, so let's actually restart this whole thing. Let's restart the process. This is a little thing I have to restart processes where you kill the process ID. The reason why this is important is because you don't want to just keep deleting your runtime because you're going to lose all your files. So this just imports the OS, gets the current process ID, and then kills the current process ID. It's just self-destructing. And then the reason why this is cool because when this self-destructs, your GPU, all this stuff gets reset. They're actually reset the computer, or I don't know what's happening on the back end, but you get to keep your file system. So I don't know how they have the file system saved, but that matters because, man, like your file system, losing your file system in Collab is a pain in the ass. It's a real pain. Okay, so all right, let's do some 10x training. Let's get the tokenizer. Oh wait, we need to data sets not defined. I thought it's because I didn't run this. So data set inside, I should show you exactly what I'm doing. All I'm doing is they have this class to organize their data sets properly, so they run through. They stop at the sequence length with 1,024 tokens, and they loop through it. They give you the input IDs. The labels are the input IDs, and they create tensors. They tokenize. The buffer is just the prompt that you have. So you want to put in an array of prompts. They're just adding that to this. Let's see. Infinite. I don't know what infinite is used for. Okay, so okay, all right. So they're just going through it forever until you hit an end, and they break out right here, and then they tokenize the buffer. And they get the input IDs after they tokenize. Remember, tokenizing is just converting these tokens, this string, each token in the string that you're passing to it, to the input IDs so the IDs that are within your system here. So within your model. And yeah, so it's yielding this in this loop. So in the end, you're creating a data set that when you use this data set, which is using this data set object, which I think this is a superset of the PyTorch, or superclass of the PyTorch data set. But this is all this stuff I'm doing here is super simple. I'm literally just getting an array. It's an iterable array because it's just a Python array of our array of prompts, and I'm just replacing it with this loaded data set right here. That's it. And then I pass it to the data set so that it can load up with this data set. And then I return it. That's it. So I didn't even have to update. I had to update this a little bit last video to make it my own and not just to make it work. That's all it is. So this ran. Let's run the tokenizer and we create the data set. This should be fairly quick, right? And then we want to get the model. Probably gonna run out of compute units for this, which is fine. Let's buy more. Oh. Sucks. Alright, so we're getting the tokenizer. and we're gonna get the model. And now it's taking so long. And then the get PFT model, really all this is doing is transforming our model to something that can using the layers to be LoRaized. So we're applying LoRA to the model so that we can freeze those layers and just train the layers that we want to train. So this is going to take a little bit actually to load the model. I just remembered. Because we're actually loading. Oh no, I already have it loaded. Pretty sure. Yeah, pretty sure I already have it loaded. I think it should be fine. Anyway, so we're loading this. We're gonna load that, and we're gonna load the training arguments. So let's just queue this. And we're gonna run the main loop. This is the loop. The trainer is a class Hugging Face uses to just do your training loop, where you pass in the model, you pass in the arguments, your hyperparameters, all these things that are just what you want to have happen here, the learning rate you want to have, the steps, everything. And then you give it your data, your eval data set and your train data set, and then these callbacks are just things that you want to have happen as you're training. So like checkpoints, saving checkpoints, things like that. And then you give it the checkpoint directory, which it saves right there. So yeah, it was already actually loaded. That's cool. So now we're actually training the model with our new data set. It's training. We'll have to see. I'm gonna like just let this train until for a little bit we can hang out. You know. This is like one of those moments where it's like, you know, when you're like hanging out with a ton of people and like all the cool people leave and it's just you and like that one guy. That's how I feel right now. No, I'm kidding. I want to see until I at least get to see one loss get calculated. And then, by the way, I made this video just because one person chatted being like, I want, like, talk about Llama. Understand how dedicated I am. I will do anything. No, just kidding. There's very few things that I will do for you guys. For everyone listening, there's very little I will do for you. Not your buddy. Not your pal. Just a coder. Okay. Alright, so it's taking a while. Yeah, you know what's also interesting is all this stuff, what I'm realizing is a lot of this is just going to go, with everything getting open source now, it's going to go in a direction where people are going to start making crazy stuff. And I'm wondering how much industry is going to be pushing this to some extent. Well, Meta is industry, and they open source this, so they probably didn't open source the best they have. So that's the way things always go with open source. Is when companies are open sourcing, same thing with like the government releasing technology and things like that. It's like these are not like the best that they have, right? Because at the end of the day, you wouldn't do that competitively. IP is important. Alright. That one guy. Hey, Nick. Nick's the only guy here. But yeah, so we're pretty much done fine-tuning. I mean, Nick, you came super late. We're already fine-tuning. Like you're already, like, Yeah. You're too late, buddy. I already explained like all this stuff. People already know how to fine tune Llama now. Came way too late, dude. It's alright. It's training. This is gonna take so. The one thing I don't understand, and Nick, maybe you can understand this is like this is like so boring. Like watch it, like waiting, specifically machine learning. Like coding's fun. Like actually like building a product is fun. But like coding the machine learning and like waiting for all this stuff to go, it's like you have to wait like hours until something. Like I was saying this the other day, like if I was a kid and I had to, when I was learning how to code when I was a kid, and like gaming's awesome thing to learn how to learn. That's what I started learning. You have to wait like 12 hours for some of these. You're like 24 hours for you to actually get a model to mess around with. That's so lame. Like I don't know how people do it. Like I'm literally just waiting for this to train. That's not 10x. You don't wait when you're 10x. Yeah, it's like, yeah, it is like you just get food. Got a bulk neck. We should do a stream where we're just working out. People are like, what is this? It's like this isn't fun. So you guys are just working out. I thought this was a code. Isn't this the guy who codes? All right, so I think I'm just gonna. I think we're good. I think I'm just gonna stop this and do some predictions, because also this takes so long. By the way, if you're training Llama 2, I'm training the 7 billion one. There's other ones. I'm just training the 7 billion one. Luckily, with all the LoRA, look, we're only using 12 gigs of the GPU RAM. I think we can actually, yeah, we can actually use more batches here. I'm going to tell my buddy Tony that. Wow, that's actually so cool. We can probably wind up using like 16 batches. It's actually really cool. Yeah, we can code at the gym next time. Next time, let's code at the gym. That's so. People already think I'm a tech bro. That's just gonna solidify it. That's just gonna solidify it. That's horrible. Let's see. Yeah, this is the. I'm gonna actually stop training this, and I'm gonna see if I can do more batches. Yeah, let's stop training. I'm gonna see if this actually. Yeah, let's stop that. Let's run. Let's see if we can do. So the reason why the generation wasn't working before is because I probably should, for the repetition penalty. So this is whenever you see repetition penalty, when you're training one of these or you're generating stuff using OpenAI, that's really saying so you don't just get the same tokens over and over again. So as you see, so I have like a little prompt here. So actually it's only, the reason why it was broken before, I just wrote this earlier today, is because it was like saying, it was giving me a ton of, oh yeah, it was only generating one token at a time. Right? So I have to do a loop here in which I re-tokenize the new prompt. Do I need to? Yeah, based on the generated prompt. And then I just keep doing that over and over and over again. So let's run this. And then I stop it if I get an end of text. Oh, I just realized I don't think Llama has end of text. This is a star coder token. So I'm just checking if the end token comes up. So when you're training these language models, there's start tokens and there's end tokens. That's how you know. That's how ChatGPT knows to stop after a while. Is that it's been taught to stop after a certain amount of, like, if the sequence is over, it has the tokens to tell it to stop. I'm also checking if there's a ton of random new line characters, and then stop, and then that's too many new lines. So I need to just stop this one though, because I just told it that you keep generating for 1,000 tokens. Let's actually see if this, interesting. So this is the code I got. This is terrible. This is terrible. We need to train this way more. So I told it to generate, at least we got some code generated though. I told Llama that I was like, this is a Chrome extension. This is all based on my data set. So I generated this data set with Node.js that's based on these prompts. Nick, this is really for you, and you're the only one here. So like, I generated for the title, the description, file name. I looked at my code, my data set. I'm trying to fine tune a language model based on my own how I code. So I have a data set, and these are the prefixes. I have the task, the description, the file name, and the code. And I just look at my own code and I build a data set like that looks like this. It's only like 5 megabytes for 3 directories. And then I say, okay, I built this little AI powered desktop app. I can run through another video. And then long story short, the way I run inference is I give it this input. Well, I don't know what all those S's are, but I give it the input that starts with Jared task, and then it generates all this stuff afterwards. This is like not at all what I wanted to do. So we're gonna have to train this for a bit on our data, and we're gonna have to get more data. But at least it's doing something now. So it's actually trying to get a Twilio client. I said using the fetch API to find news data. You know what's funny? With StarCoder, it was actually like working more. So maybe we should just use StarCoder, even though it's kind of clunky. But all right, so we're actually like getting my to-dos. When you're 10x, you give yourself to-dos, okay? When you're a 10x engineer. Do you know what 10x engineer is, Nick? Like where that meme came from? That's just a thing people have been saying so much in tech. They've been like calling things, oh, that's how to be a 10x engineer. It's like so dumb. It's like, it's actually so, but I love it. I love saying 10x. But yeah, so if you want to know, watch this video, rewatch it. If you want to understand what Llama is, what LoRA is, how to train thing, how to fine tune, what fine tuning is, what we're doing fine tuning this, watch it over again. If you want to become 10x, you gotta subscribe so you can watch more videos of mine, so you can actually learn how to code. I have a ton of streams where I talk about how to code, where I run through different projects. For now, adios. Yeah, this is like my HTML project. So like I'm making this I can run through that on another video where I have this like this big project where I'm trying to actually like on just a single GPU, super small computer, where I'm trying to train a model that can actually creatively write HTML and like design things, and it's not like GPT-4, it's not like huge, and it's something you could just probably run inference on in a CPU. So I'm gonna have a stream on that. That's gonna be a really good stream. But all right, I'll see ya till next time.